Hello students, welcome to grade 10 chemistry class. The topic which we are going through is periodic classification of elements, and today is the last session of this topic. In the previous class I have taught you already about the properties of elements, how they are going to change in periods and in groups. The properties that we have discussed in the earlier classes are valence, valency of elements, atomic radius, ionization energy, and the factors affecting ionization energy. Now, in today's class, you're going to learn about the properties like electron affinity, electronegativity, electropositivity, and so on. Now, let's see what is electron affinity. Electron affinity is also known as electron gain enthalpy. And this electron gain enthalpy gives you the complete explanation of electron affinity. So here electron gain enthalpy means this obviously tells us that it is gaining of energy because of electron. And this electron, whether it is addition or removal, you should just get a clarity. Now let's see what is electron affinity. Electron affinity is defined as the amount of energy liberated when an electron is added to neutral gaseous atom. So what is electron affinity means? It is the amount of energy liberated, that is given out, when an electron is added to neutral gaseous atom. So when an electron is added to a neutral gaseous atom, then certain amount of energy is released. This amount of energy that is released, means that is liberated or that is given out, is known as electron affinity or electron gain enthalpy. Now let's see which elements or what can release this energy. The elements that can release is atoms of some elements gain electrons while forming ionic bond or ionic compounds. So here when this electron gain enthalpy is possible is when atoms of some elements, when they gain electrons during the formation of ionic bond, then electron gain enthalpy is possible. That is, atoms of certain elements during the formation of ionic bond, they release energy and at the same time they gain electron. Then in such cases certain amount of energy is released, and this released energy is known as electron gain enthalpy. So the condition is that this electron gain enthalpy is observed when ionic bond or ionic compounds are formed. And let's see which elements or which atoms can release this energy and how they are able to do it. An atom is able to gain electron only when the electron outside the atom is attracted by the nucleus. So here when an atom can release energy is when it is able to gain electron, then it can release energy, and this gained electron should be outside the atom, not within the atom itself. This gained electron should be outside the atom, that is attracted by the nucleus. For example, consider a chlorine atom is involved in the bond formation. So this chlorine atom, when it gains electron from the other atom, not from the same chlorine atom, when it gains electron from the other atom, that is outside the chlorine atom, then certain amount of energy is released, and this is known as electron gain enthalpy. All the factors that influence ionization energy would also influence electron affinity. So here the factors that influence the ionization energy are nuclear charge, screening effect, penetration power, stable configuration, and atomic radius. So the factors that influence or that affects the ionization energy will also affect the electron affinity. For example, nuclear charge, the first factor. If the nuclear charge is more, ionization energy is more. The same way, when the nuclear charge is more, it can easily attract the electron outside the atom. So nuclear charge, the more the nuclear charge, the more is the electron affinity. The next factor, screening effect, which means the number of orbits. If the number of orbits are more, ionization energy is less because they act like screens. So electron can be removed easily. But here, screening effect, the more the screening effect means distance from the distance of nucleus towards the outside electron is more, then it cannot attract easily. So the more screening effect, less is the electron affinity. The next, penetration power. So here penetration power means ability of the electron to get closer to the nucleus. So when it is closer to the nucleus, then electron gain enthalpy will also be more. The next is stable configuration. So atoms with stable configuration will have more energy, means they are not ready to react. So for these atoms, the stable configuration, atoms of stable configuration will have higher electron affinity. The next is atomic radius. The more the atomic radius, then less is the electron gain enthalpy. So attraction involves liberation of energy. Why the attraction involves liberation of energy is due to the change of energies between the reactants and the products, formed products. It involves liberation of energy. So the elements before reaction will have certain amount of energy, and after the reaction, that is after gaining the electron, the energy of them changes. So here the change in the energy is given out as liberation of energy. The energy liberated when an electron is added to a uni-negative ion of an element is called second electron affinity. You all know that electron affinity means amount of energy liberated when electron is added to neutral gaseous atom. So to this neutral gaseous atom, when electron is added, it becomes uni-negative. Suppose to this uni-negative ion, if one more electron is added, then still some amount of energy is liberated, and that energy is known as second electron affinity. It was observed that electron affinity of halogens, means seventh group of elements, are as follows. The group of elements fluorine, chlorine, bromine are known as halogens, and the electron affinity values of them are as follows, like fluorine minus 328 kilojoules per mole, chlorine minus 349 kilojoules per mole, bromine minus 325 kilojoules per mole, iodine 295 kilojoules per mole. So if you have observed the electron affinity values in this group, fluorine is minus 328, whereas chlorine it is minus 349. So here it had increased. So you must be thinking that the electron affinity values increases in a group. But if you observe still further, you can see that the value of electron affinity for bromine is minus 325, which is less than chlorine and fluorine. Same way, iodine, it is minus 295. So from this we can say that the electron affinity values in group decreases. But what is this again? Fluorine and chlorine. Chlorine has higher electron affinity than fluorine. This is an exception because chlorine, with its electronic configuration of 17 electrons, is ready to gain one more electron easily. So its electron gain enthalpy is more than fluorine. Hence, we can say that electron affinity or electron gain enthalpy decreases in group but increases along the period. This leads to a fact that electron gain enthalpy of alkali metals have low enthalpy. We know that the first group elements are alkali metals, and second group 2A group elements are alkaline earth metals. And it was observed that in period electron affinity increases. So alkaline earth metals should have higher electron gain enthalpy values than alkali metals. So alkaline earth metals have higher values of electron affinity than alkali metals. It was also observed that alkaline earth metals and noble gases have positive values due to completely filled s orbitals. Why the alkali earth metals have more electron affinity or higher electron affinity than alkali metals is the s orbital in them is completely filled. The same way noble gases, they have octet configuration. So here stable configuration is showing its effect on electron gain enthalpy. So for these elements which have stable configuration are having more electron gain enthalpy. And it is common in group that electron gain enthalpy decreases in groups, whereas in periods it increases. Now let's see the other factor, that is electronegativity. So here when you compare the abilities of elements to attract the electrons when their atoms are combining. So when atoms are combining, here there is a need to compare the abilities of the elements. This ability of the elements can be compared with the relative scale which is known as electronegativity scale. So to compare the abilities of the elements, this electronegativity scale was introduced. And here electronegativity means the electronegativity of an element is defined as the relative tendency of an atom to attract electrons towards itself when it is bonded to atom of another element. So how can you define electronegativity of an element is, it is the relative tendency, means comparative tendency of an atom. Means here when you are defining the electronegativity of an element, it is compared with other element in during bond formation. So here when the compared element is involved in a bond formation, its ability or its relative tendency to attract the shared pair of electron towards itself is known as electronegativity. For example, consider the electronegativity of chlorine atom. And this chlorine atom is in bond formation with some other atom like hydrogen. Then here the tendency of the chlorine atom to attract the shared pair of electron towards itself is known as electronegativity of chlorine. Did you all get what is electronegativity? Electronegativity of an element is defined as relative tendency, means comparative tendency of an atom with the other atom which is in or which is involved in the bond formation. What is the tendency? To attract electron towards itself when it is bonded to the atom of another element, not same element. So here you cannot compare or you cannot define electronegativity of chlorine when it is forming chlorine molecule, because during the formation of chlorine molecule, a chlorine atom will combine with another chlorine atom. So there is no relative comparison because both the atoms are having same tendency. So remember that electronegativity can be defined as the relative tendency when it is involved in the bond formation with other element, not with the same element. And how can you define the electronegativity of an element is, it is defined as the relative tendency of an atom to attract electrons towards itself when it is bonded to atom of another element. All the influencing factors of ionization energy and electron affinity influence electronegativity values. Even the factors that affect the ionization energy and electron affinity will also influence electronegativity. Okay. Now, Millikan proposed electronegativity as the average of ionization energy and electron affinity because this is related to the amount of energies liberated and the tendency of the atom to attract. This electronegativity can be defined or can be calculated as average of ionization energy and electron affinity. That is IE plus IA by 2 is equal to electronegativity of an element. So this was observed and proposed by Millikan. Then Linus Pauling assigned these values on the basis of bond energy. Later on, Linus Pauling has assigned the electronegativity of all the other elements basing on bond energies of them. He assumed electronegativity of hydrogen as 2.2 kilojoules per mole and calculated other elements with respect to hydrogen. So first he calculated the electronegativity of hydrogen as 2.2 kilojoules per mole experimentally, and as or with respect to hydrogen atom he calculated the electronegativity values of other elements. Remember that Millikan has proposed the electronegativity value as average of ionization energy and electron affinity, and Linus Pauling has given the values of electronegativity of other elements with respect to hydrogen. It was observed that the electronegativity in groups decreases and increases in period. So here the electronegativity values decreases in groups and in periods it increases. So basing on this fact, the most electronegative element is fluorine because it is the element in the second group which has the highest electronegative element. It has highest electronegativity value, and since the electronegativity value is decreasing in group, so the first group of elements will have the least electronegativity values, and among them cesium is the element which has least electronegativity value. Then next is electropositivity. The opposite of electronegativity is electropositivity, that is tendency of the atom to lose electron and convert into positive ion is called electropositivity, and the tendency is opposite to electronegativity, that is electropositivity decreases in periods and increases in group. So here the electropositivity decreases in periods. So here first group of elements are having more electropositivity, and this electropositivity increases in group. So cesium is the most electropositive element and the most electronegative element is fluorine. Remember that the most electronegative element is fluorine, least electronegative element is cesium, which means that it is most electropositive element. So which is the most electropositive element? Cesium is the most electropositive element and fluorine is the most electronegative element. The next is metallic and non-metallic characteristics. Metals are highly electropositive elements. So here we all know that metals are highly electropositive elements. So electropositivity increases in group, hence metallic character also increases in group and decreases in periods. Whereas non-metallic character decreases in group and increases in periods. It is vice versa. So here remember that metals are highly electropositive elements and this electropositivity increases in group. So metallic character increases in group, whereas non-metallic character increases in periods. That's it. Let's see with an example, that is considering the third period elements: sodium, magnesium, aluminium, silicon, phosphorus, sulfur and chlorine. So here, among these elements, we all know that sodium and magnesium are metals. Aluminium and silicon are semi-metals, means they are like they are metal, they have the properties of metals as well as non-metals. So they are known as metalloids or semi-metals. Then phosphorus, sulfur and chlorine are non-metals. So here, when you observe the periodic table, the elements which are present on the left side of the periodic table are metals, and the elements which are present on the right side of the periodic table are non-metals. Between them, there are metalloids which are known as semi-metals. I think you must be very clear here. Metallic character increases in groups because metals are highly electropositive elements, and electropositivity increases in groups. Since the electropositivity is increasing in group, metallic character increases in groups and non-metallic character increases in periods. This can be observed in the periodic table. So when you observe here the periodic table, the metals which are present, all the metals which are present on the left side of the periodic table are metals. The elements which are present on the left side of the periodic table are metals, and which are present on the right side of the periodic table are non-metals. And if you observe this zigzag line, all these elements which are close to this line are metalloids. And here are noble gases: helium, neon, argon, krypton, xenon and radon. So this eighth year group of elements are noble gases. So remember, left side of the periodic table are metals, right side of the periodic table are non-metals, and the zigzag line, along the zigzag line are the metalloids. So with this we have completed all the properties of the elements along the groups and periods. Now when you generalize the properties of the elements along periods and groups, that can be easily depicted through this figure. That is atomic radius. Atomic radius means distance from the center of the nucleus to the outermost orbital of an atom. And this atomic radius increases in groups, whereas in periods, that is from left to right, it decreases. So you can see that the arrow mark is moving from right to left. So here the atomic radius is decreasing in periods and it increases in groups. The next is ionization energy. Ionization energy is increasing in periods, whereas in groups it is decreasing. The next is electron affinity. Electron affinity also increases in periods. The next, metallic character. The metallic character decreases decreases in periods and increases in groups. So left side of the periodic table are metals, right side of the periodic table are non-metals. So remember this picture so that which can help you to answer the many questions, and the information which you get from this is applicable in understanding the chemical properties or the bond formations of different atoms. So with this, we complete the lesson of periodic classification of elements. So here, I hope that all of you have understood the topic well. Once again, go through the video and then answer the given assignment. Don't be lethargic. Do little bit of bending and stretching exercises and have proper diet. Okay? Stay safe, stay home and stay safe. Thank you.